Let us now handle this other question on sequence and series of numbers. We are given the sum Sn of the first n term of a geometric progression as Sn is equal to 3 into 1 minus 2/3 to the power n. And we're asked to find the common ratio, the fifth term, and the sum to infinity. Alright, let's start with what we have been given. The sum of the first n term is 3 into 1 minus 2/3 to the power n. Okay, now we know that to get the expression for the general term, when the expression for the sum of the first n term is given, that expression is gotten from Sn minus 1. This is the expression for the general term. To get it from the expression of the sum of the first n term, that is how we progress or proceed. Alright? Sn is just that, so we have 3 into 1 minus 2/3 to the power n. Now, minus Sn minus 1. Minus Sn minus 1. Let's write it down. What is Sn minus 1? Sn minus 1 is this same expression where we now replace n with n minus 1. So we have 3 into 1 minus 2/3. This time the power is n minus 1. So it is this expression minus this expression. Okay, so let's try to write it on a single line. We have 3 into 1 minus 2/3 to the power n minus 3 into 1 minus 2/3 into the n minus 1. This is the expression for Tn. Alright, we see 3 is common, so we can write 3, we'll write it once into 1 minus 2/3 to the power n minus, this minus will open this parenthesis with respect to this minus multiplied to 1 minus 1, this minus multiplied to minus 2/3 become positive, minus positive, positive 2/3 to the power n minus 1. Alright, that is our Tn. Let's look at the things inside the parenthesis. We have 1 minus 1, 0. We have 3 into 1 minus 1 is 0. Then we'll have this one which is positive. We can start with it. 2/3 to the power n minus 1 minus this minus here minus 2/3 to the power n. Alright, that is our Tn. Okay, so when we look, we can continue our simplification. This gives us 3 into, this is 2/3 to the power n divided by negative 1 means divided by 2/3. Okay, remember a to the negative n means 1 all over a to the n. Alright, and so 2/3 to the negative 1 means 1 all over 2/3, which is the same as divided by 2/3. And so we write it as such. This expression is the same as this. Minus 2/3 to the power n is our Tn. We see 2/3 to the power n, 2/3 to the power n common. So we have 3 into 2/3 to the power n, factorizing out that completely. So we have 1 all over 2/3 divided by 2/3 is the same as 1 all over 2/3 minus 1 is our Tn. So what do we get finally? We have 3 into 2/3 to the power n, 1 divided by 2/3, the 3 just goes up, so we have 3 all over 2 minus 1. That is our Tn. To further our simplification, 3 all over 2 minus 1 is just going to give us a half. Let's look at it. 3 all over 2 minus 1. We can also write that as a fraction. LCM is 2. 2 divided by 2 is 1 multiplied to 3 is 3. 2 divided by 1 is 2 multiplied to 1 is 2. So we have a half. Alright, so 3 all over 2 minus 1 is a half. So we finally have 3 to 10 to the power n into a half. That's the expression for our Tn. So finally, our Tn can just be rewritten as 3 multiplied to a half is the same as 3 all over 2 into 2/3 to the power n. This is the expression for our Tn. This is the generator for all the terms of that geometric progression. Our Tn is 3 all over 2 into 2 all over 3 to the power n. Alright, so let's continue up here. Now we know the expression for Tn. We know the expression for Tn as 3 all over 2 to 10 to the power n. So from here we can generate the first 3 terms. Our T1 is when n is 1. So we have 3 all over 2 into 2 all over 3 to the power 1. That is just 3 all over 2 multiplied to 2 all over 3, which is 1. So our first term is 1. Now our second term, alright, we replace n with 2, 3 all over 2, 2 all over 3 to the power 2. So it is 3 all over 2 multiplied to 4 all over 9. And so we can see 3 here 1, 3 there 3. Alright, so we have 3 under, 2 here 1, 2 there 2. So we have 2/3. Okay. Our third term is 3 all over 2. We replace n with 3, 2 all over 3, 3. And so we have 3 all over 2 multiplied to 8 all over 27. Alright, 3 cubed is 27, 2 cubed is 8. So 3 here 1, 3 here 9. So we have 9, 2 here 1, 2 there 4. So we have the first 3 terms as 1, 2/3, 4 all over 9, and so on. That is, these are the first 3 terms of our sequence. Okay. We already know that our sequence is a geometric progression. Therefore, how do we get the common ratio? Our question says we should get the common ratio. Our common ratio is gotten from second term divided by first term. Okay? Or third term divided by second term. All of that will give you the same result. So if we take this first one, we have our second term is 2/3 divided by 1, which is just 2/3. If we were to work with this, our third term is 4 all over 9 divided by our second term. Alright? We maintain the first fraction, change this to multiplication, and invert the other one. And so we'll see 3 here 1, 3 here 3, 2 here 1, 2 there 2. So this gives us 2/3 again. So whichever expression you choose, you get the same value for the common ratio. Our common ratio is 2/3. Next, we're asked to find the fifth term. Since it's a geometric progression, and we have the expression for the general term. The expression for the general term here is 3 all over 2 is our expression. 3 all over 2 2/3 to the power n. Therefore, T5, our fifth term is T5. That means we replace n with 5. So we have 3 all over 2 into 2 all over 3 to the power 5. Alright? So, how do we get this? This is just 3 all over 2. 2 to the power 5 is 32. And 3 to the power 5 is 243. 3 to the power 5 is 243. So that we can simplify that out to get 2 here 1, 2 there 16. 3 here 1, 3 here 8, 81. So this gives us 16 all over 81. So this is our fifth term for that geometric progression. 16 all over 81. Now, the last thing we're asked to find is sum to infinity. Sum to infinity, written as such, has a formula. It is the first term all over 1 minus our common ratio. So this should be equal to our first term. Our first term we found it to be 1. So we're going to have 1 all over 1 minus our common ratio. Our common ratio we found it to be 2/3. Right? So we have 1 all over 1 minus 2/3 is just 1/3. Right? Which will now give us our sum to infinity as 3.